Hi there, welcome to Btree. This is Thiru, author of Btree. This is our third video and the continuation of the tree data structure, and today we are going to learn about representation of binary trees using arrays and linked lists. If you are completely new to the tree data structure, I would recommend you to watch the previous two videos. You can find the link to the playlist here in the info or in the video description, and I also request you to please subscribe to the channel if you are not yet subscribed. Also please share the channel with your friends. Let's dive into the topic without making any further delay. The primary reasons for representing trees using arrays or linked lists are related to memory management, efficiency, and ease of access. We choose arrays or linked lists based on the requirements. Generally, arrays we use for fast access in complete trees and linked lists for dynamic size and flexibility in sparse or unbalanced trees. So now let's start with the representation of binary trees using arrays. So keeping in the mind the relationship between the parent and child nodes of a tree data structure, we need to store the relation also of every parent and child nodes in the array. So to achieve this, we can store level after level in array from left to right. So here in the diagram you can see there are three levels, level 1, 2 and 3, and we have total 6 elements where there is one element less in the last level, right? So at level 1 there is one element, that is root element A, and we can store it as a first element in the array. And in the next level, that is level 2, we have two child elements, that is B and C, and we will store them in the array from left to right. Finally, from the last level, that is level 3, we have three elements D, E and F. Of course, we will store them from left to right. Here we need to note one thing, that is there is no left child for the element C, right? So for that we can store a null value in the array, but I am not showing that here in the array representation. But whenever we code the array representation of binary tree, we will store the null values if they are present in the middle, okay? I hope now you understood how to represent a binary tree using array. So also, whenever a binary tree is represented using array, we can determine the relationship between the parent and child nodes using the indexes. So if we start with the first level, that is from the root's index is 0, right? And its childs are B and C, they are positioned at 1 and 2 indexes, right? Similarly for B, the childs are D and E, they are positioned at 3 and 4th index. At the 5th index, we should place null value, and then at the 6th index, we need to place a F, right? But here we just placed the last element in the last index. So if we trace the relationship between any parent and child nodes with respective of array indexes, the left child will be situated at 2 into I, that is index of the parent plus 1, and the right child will be positioned or placed at the 2 into I plus 2 index, okay? I hope now you are in a situation to understand how the relationship can be determined between the parent and child nodes when a tree is represented by array, okay? Now let's explore the next one, that is how we can represent the binary tree using a linked list. Generally, we represent binary tree using a doubly linked list. In a doubly linked list, each node can link with other two nodes. And we know that in binary tree, a parent can have max 2 children, right? So doubly linked list is the very precise one to represent the binary tree. So here I'm just showing a Java snippet how a node can be represented, okay? So node in the linked list will have a value and the left and the right connection, that is left and right childs, right? And then a constructor to assign the value to the node. And then the diagram below the binary tree, you can see those are the linked list nodes and they are connected to each other, right? And every node has left and right child similar to the binary tree. So this is how the binary tree can be represented using the double linked list. So while constructing the tree only using the linked list, we can place the nodes in their respective places or the respective nodes, and no need to maintain any index kind of relation. This is in place. You can note here one thing, C has no left child, right? So while representing with the linked list, we can represent the C's left child as a null, okay? That is simply C will have a left pointer as null. So this is how we can represent binary tree with arrays and linked list. And so far I have just represented how we can construct a binary tree with array and linked list. But practically through code, whenever we need to implement this, we need help of one more data structure, that is queue. So programmatically, while converting from a binary tree to array, we need to perform some more intermediate steps, and I will show them now. So we will take one queue and the resultant final array, and at first we initialize all the array elements with the nulls. After that, as a very first step, we will bring the root element to the queue, that is A, right? And now again we need to take the same element from the queue and we need to put that in the array. So the first element in the array will be the root, that is A. After putting an element from queue to array, we need to ask a question, does that element have left child and right child? Okay. If the answer is yes, we need to take that child element and we need to put them in the queue. So here in the case, B and C will come to the queue, and next we need to dequeue their parent element, that is A or root, which is already got inserted into the array, right? At this moment, you can see the first level elements, that is root, got inserted into the array, and for the next set of levels or the elements, we need to follow the same process. So now for the element B, the childs are D and E, we will put them in the queue and we will dequeue the element B. And for element C, it don't have the left child, it has only the right child. So we'll put the null and F in the queue and we'll dequeue the element C. At this point, we completed putting the level 2 also in the array. And stepping down to the last level, no element have the child elements, right? So we'll dequeue all the elements from the queue and we will put them in the array. We have completed the construction of the array from the binary tree, right? This is how programmatically it looks like when we convert a binary tree to array. So when we need to convert from binary tree to linked list, we don't need any intermediate data structure. We can just link the nodes as it is in the binary tree. Now let's jump into the code implementation from binary tree to array. First, I'm implementing in Java from binary tree to array. So at first we need to implement the node class, which I have already shown you, right? Then I will define another class with main method, in which we need a basic binary tree, right? So we will create that in the main by initializing and linking the nodes. So here I created the same binary tree which we used in the example. Let's define a new method for the actual logic. Inside this new class, I'm defining a method from tree to array. Okay. This method will take a root element of the tree as a parameter. So if the root element is null, that means there is no tree, then we can just return an empty array. So here I'm returning return new int of 0. Then for the actual implementation, as we discussed, I'm taking a queue, then put the first element, that is parent or root, to the queue. In Java, even a list we can convert it to array. So for ease of use, I define the list here, in which we will fill the tree elements. Now, as per our logic, we know we need to put the elements level by level in the queue. Then we insert them into the list. At the time we reach the last level, the queue will be empty, right? So the same condition I am putting here. While the queue is not empty, we will perform that, taking the elements from the tree and putting in the queue and then list. So inside the while under if condition, if you see if any node is not equal to null, we are taking that node and putting in the list. Also, we are taking the left and right elements of that node and putting them in the queue. Otherwise, if node is null, we simply putting that in the list. Once this process is done with all the nodes, we can simply trim the list that is nulls at the last. Then we can convert that list to array, which is representation of the given binary tree. Then we can return it to the color function. So this is all about the Java implementation from binary tree to array. You can take the screenshot of this Java code implementation if you want. I will also provide the GitHub link in the description. Now let's see the Python code snippet or the Python implementation for the same. So this is Python code implementation from a binary tree to array. There is no difference what we discussed with the Java code. You can take a note of this. You are a Python B. And finally, I'm not showing you or the code implementation from binary tree to linked list here. As I explained you earlier, it's very easy. You just need to define the nodes. Then you need to link how the binary tree is visible. You can try it yourself. If you find difficulty, I also provided the link for that also in the GitHub link. You can follow with that. So that is all about the binary tree representation using arrays and linked list. I hope you find this video is helpful for you. Please subscribe to the channel if you are not yet subscribed and share the channel with your friends for upcoming learnings. And we'll see you in the next. Thank you.